hello right there. Welcome to today's tutorial. My name is Darlington Gospel as always, and if this is your first time of being here on this channel and you have not subscribed, please smash that like and subscribe button, hit that notification bell, and if you are a returning viewer, you know what to do. Please hit that like and subscribe button as well in case you haven't actually subscribed. So in this tutorial today, we are proceeding from where we stopped in the recent one. In the last tutorial, we built the smart contract version, or the back-end version of this voting application, and in today's tutorial I would like to continue from there and to show you how you can merge an anchor program in Solana in your Next.js front end. Okay, this particular tutorial is going to feature not only the integration angle of it, but we're also going to do deployment. I'm going to show you how to set it up on a local host connection so that you won't have to spend a whole lot of Solana tokens to test out your application. Even though that is test is a shitcoin, it's really not valuable. All right, so that is what we want to achieve in this tutorial. I was able to go through the process. And also, this sort of tutorial, there are not a lot on the web, you understand that? So you will not find the ideas that I am actually incorporating into this tutorial, into this Solana build, just anywhere. The ones that you're going to find are obviously old. Okay, so what I'm teaching here is like the top notch. I have been able to do it through rigorous research, a lot of deep, things have come to light, and we're able to achieve this. Okay, so now that is what you're going to be doing in this tutorial. We're going to build everything from, not really from scratch. I've already prepared the front end to really make sure things are faster for us, because I don't want to be writing HTML and CSS code or Tailwind codes. It has to be prepared to make this tutorial a lot shorter. What I'm just going to be doing is the integration and merging the back end with the front end. We're also going to be doing deployment as well. I'm going to show you how to deploy on LocalNet and also on Devnet as well. And I think I've also hosted this thing online, and I've done this already multiple times, so it should not be such a big deal for you to host it online yourself, so long as it's deployed on Devnet, Solana. So with that said, let's jump into the tutorial. I'll show you the demonstration of everything, then we can proceed. All right, so this is what we get from, this is the application right now. I think I may have to disconnect this and start it off from scratch. So I'm going to just, everything works, even without you connecting your wallet. You'll be able to see the details of what is going on. Like here are all, a list of all the, polls that are currently ongoing. It tells you the start date and the end date. I didn't go about making a whole lot of aesthetic investment into this application, but trust me, it just works just fine. And since it's for demonstration purposes, it's not really a requirement that it must be stunningly beautiful. Okay, so this is our first poll, and the poll, when you click on it, it shows you the details. Literally, this is the PDA of this poll. So this gives you information of where the poll is on the Solana Explorer or blockchain, and you can see the full name, say safest country in the world, and you see the poll when it starts and when it ends, and the number of candidates. And you can see the candidates, one is El Salvador, the other one is Poland, so El Salvador is actually hitting 2 right now. So how about we create a fresh one from scratch? So you can create one, but you can create until you connect your wallet. You see, this is disabled, so you have to connect your wallet, and I've connected my wallet. I could create a new one. Okay, which one should we create? Best learning platform. Okay, so this, I want it to already start, so I'm kind of like going to start it from yesterday, which is 25th, and then it should stop like in Yeah. Okay, so then I could create this pool, click on create, and it's going to authorize. Now this is running on the devnet. Okay, so I'm going to confirm that. Confirm. By the way, this is making use of the smart contract that we've already created in the previous tutorial. Please, if you haven't watched that tutorial, you should do that. Okay, why this is delaying? Because it needs to confirm this transaction first before releasing. Now this has been confirmed. It means that if we come to the main, if I open the console, I should be able to see the transaction ID right here. Okay, and not only that, if I come to this place, you can see that that pool has been listed, and you can see that it has zero candidates. If I check here, go to Explorer for Solana, and I need to go to Devnet cluster, paste this transaction, go inside of it, you will see what happened. You can see the various number of accounts that we used here. These are the various accounts we've been creating. I mean, Solana is really, really great. I actually like the idea of what they do to Solana. If you come here, you'll be able to see the particular instruction that was executed. You can see that it's the create poll instruction for this particular transaction. So those are some really cool stuff that you should take note of. So now that we have that, and you can create a candidate, and you can create a candidate by coming here and click on this button. Okay, let's create 2 candidates. We're going to say YouTube. Okay, YouTube. All right, register that candidate. We're going to come here, click on confirm. I'm going to say YouTube and let's say Udemy. Okay, so those 2 will be great. All right, so there we go. And also want to add another candidate. Let's say Udemy. Register that. Confirm. You can see how this application is just working very smoothly. Everything is hosted on Vercel right here. Like, I'm not even doing it from my local host connection, but I'm just doing this for test purposes so that you can see how it works online. At each time, because we're using Redux, you can see the number of candidates is 1, so everything just happens dynamically. You can see it increased by 2, and you can see the number of days. So I'm going to say vote for YouTube. Okay, confirm that as the best learning platform. It may surprise you, but I actually learned most of my learning, most of all the things that I know on YouTube and other blog aspects. It's like 0.00% of my learning has come from Udemy. And you can see once you have voted, this button is disabled. You can't vote anymore. It's not allowing you to vote. Okay, you can see that voted 1, and yeah, I can also vote for this as well. I have El Salvador, we have Poland. I think I've voted for El Salvador before. I don't know if this account has voted, but let's check it out. So let's confirm that. If it's voted, it's going to fail because, okay, it hasn't voted. Otherwise, it should have disabled this button. So we made preventions for double voting. Okay, so I'm going to do that. Okay, voted 3. That is pretty fantastic. So this is how the polling application works, called Votee. So this is what we did with our smart contract, and now it is on the web, integrated properly, everything working as usual as a regular Dapp. All right, so with that revealed to you, let's jump into this tutorial and start processing this project. I'll see you in the next part of this video. All right, so before you proceed with this build, I've already prepared a starter kit. Okay, I do this to make sure that we are all on the same page, because I don't want people having issues with one plugin or the other, one package or the other. It's a sure way that you will be working in the same code structure with me. Okay, so but I've actually removed a lot of integration, all the integration features. I just removed it and only kept the part where we'll have to start from. Okay, so I will need you to copy this endpoint. You go to github.com/diatonic/vote. I'm going to drop the link to this repository in the description section so that you can have access to it. Then you need to clone this project. So to clone that, or you can just do search for terminal. Okay, I need to seed into sites. That is where I keep all my code. Let me increase this. Okay, so I'm gonna do you know that you need GitHub, Git bash installed on your terminal. You need that installed, and you need Node.js installed. You don't need me explaining all these things. This is how it normally goes. All those packages. All right. So this Git comes with Git bash. All right. So you need to have that installed. So Git clone. If you don't know what Git bash is, just check on the internet right here and install it on your Mac or your Windows or whichever, or Linux, whichever system you're using. All right, so I would say git clone this repository, and I'm going to give it an alias, which will be, I'll call it vote YT for YouTube. Okay, so you need to clone that, and it's cloned successfully, and then I'll open it. Say seed into, no, I'll open it on VS Code. That is what we use here. Okay, VS Code will help us to make sure that everything is aligning, right? So, and please make sure that if you're coming to watch this part of this video, you've already watched the previous one where we developed the application step by step. Okay, so this part is is based upon what we've already done in the previous one. So this is that previous tutorial is a prerequisite for you to excel in this one. So say cd into vote YT. Oh, I could just open it code this directory on VS Code. So here we go. I'm going to bump the size of this so that it will not be too small for us to see. All right, so this is our project. This is basically what we did before. You can see this is the anchor part, and you can see the program that we worked on before, all of those things. Okay, so this is what it is. And before we proceed right here, let me run npm install. So let's open your terminal and run npm install, short form for install. So it's going to install these modules that are found here. So these are all the modules that are used in this application, so that you won't have to look for them. Something like React icon, Redux, I added Redux, you added Toastify, and this is Redux toolkit, so we added quite a lot of those. So while this is installing, I would like to show you, let me open it up here. I'd like to show you a little modification from the last time that we worked on this smart contract that I did. I missed out this little tiny detail. So if I come to instruction, and in the place of registering candidates, there is this line of code that I added, which is this line. Okay. Now the reason why I added this line is because, if you come to the base version, or even the refactored, let's just go to refactored. My network is a little bit slow now since I'm running a process, down here. Okay, refactored, coming to anchor. All right, so we have factored anchor, instruction, and we have register candidates. You can see that in the registration of this candidate, whenever I register a candidate, I forgot to increase the number of candidates that a poll does have, which is very important, because if that is not incremented, it will not show up. It will not increase in this place. You can see this increasing. Okay, so we needed to increment that, and so I made that modification in here in this main branch. Okay, now we've installed everything, but we are not working from this main branch because this main branch has the finished version of this code. So we want to shift to this starter branch. We have a starter branch. So how you can do that is you can say git checkout starter. You can see I've switched to starter branch now, so all my code is going to be based on that. And if let's close this now. Since I've shown you that little modification, please just understand that we did that to solve a little problem. You will not need to touch this Anchor project, at least from my end. Why I'm saying from my end is because you may need to change you may need to change this declared ID, this program ID, because once your own is generated, okay, you may need to change it to whichever one that will suit. And please, when you're changing it in this main file, also make sure you change it in this anchor place as well. You can see how I changed it here as well. Okay, so I'm going to explain more about that. So that is the only things that you need to take note of in this anchor place. Please, for deployment reason, if you want to deploy to local net, you can describe the ID of that program, what is going to be on local net. So this is it. What about on DevNet? This is also it. If you also have mainnet, you also specify as well. So for this, I've made sure that the program ID are the same across these various clusters of the blockchain of Solana. And then you need to provide the default cluster, which is local net, which is the one I'm putting here. That is just some little changes that I did to the smart contract. So that's it for it. Okay, let's proceed here. If you come to this src source, you can see all the files here that I do have. It's just the basic things. But if you come to this main branch here, and then I come to this main branch, you find out that there's just a lot that has to do with this. You can see we have component, we have things like services, store, and all that utils. Okay, so we're going to make all those changes as we go. Let's start this application. I'm going to do yarn, or you can use npm. Let's use npm run dev. Okay, so this is going to spin up on our local host. So you copy this line, come here, and before I proceed, there is a very important thing that you need to take note of. Okay, so if I do code.env, okay, I think I published this environment variable, which I shouldn't, so I'm going to make it, I shouldn't, but it doesn't contain such a sensitive information though. So what happened is that you need this Next.js, next public key RPC URL. This is the URL for localhost, and this is the URL for, DevNet. So anyone you're working with, you need to make sure that will be the default. So make sure that you have a .env file where you have this clearly spelled out. So if you have that, that is good. And let's start up this again. So npm run dev. All right. So and then you check on the browser. I'm gonna come to localhost 3000, and I have. These are just dummy information, okay? There's really nothing about them, nothing special. You can see all these are just dummy information, okay? So that is what we did, and we are on the same page right now. Okay, so I'm going to close all this and let's start our development. So the first thing I want to do is let's set up all the necessary setups. Okay, one of the settings that is required is for you to run your validator node. Okay, so to run that, you need to do Solana. Please, you should already have all these things installed, because if you watch the previous tutorial, all these things were discussed. Okay, so Solana test validator. I'm going to put /reset right here. So Solana blockchain is being spinned up. All right, here we go, and it's working. Okay, so I'm going to deploy a smart contract into that chain right now. So to deploy it, I need to go into this Anchor folder, our smart contract. We need to put it there. So say cd into Anchor and say Anchor deploy. I need to build it first. I could decide to build it. Yeah, say Anchor build. Okay, so it's going to take some time for it to build, and once it is built, we'll come back. So compilation is completed, and now I could do yarn deploy to put it on the network. Okay, this is defaulted to localhost. Okay, so but this isn't obeying, is actually generating a new ID. Okay, so you can decide to change the ID. Okay, that is up to you. So I'm going to for the sake of this tutorial, let's just change this ID. I'm going to use this ID, and we're going to have to modify our code a little bit. Check our program, and okay, so this right here, I'm going to have to change this. After changing that, you also need to change it on localnet here. You need to change it here as well. So those two places, so that you can proceed, because don't understand why Anchor is just so bent on generating new key pairs for us. I think that should be an instruction. Maybe I don't just know, for data mining. It should really be easy for you to generate new key pair instead of Anchor generating it for you, so that in case you want to change new one, you can easily just generate it and change it there, instead of having to force you into doing that. Okay, so I'm going to close this now that we have that. So then I'm going to build this again, because I made those few changes, and after building that, I will deploy to that network again. Okay, so we are cool. I'm going to copy this address. You know that we have Solana blockchain running right here. So we need to come to Explorer, come to explorer.solana.com. We're not looking for this on the mainnet. We want to look for it on not the Devnet either, but the custom RPC. Now, this is where you need to understand something. You see that this is crashing. This is not working out for me, on this Brave browser. I've tried every single thing, and then I found the solution. Not even Safari browser could help me here. And I found out that this has to do with the kind of browser that was being used. So I decided to check out. I did some checking online, and then I found out that you can actually use Mozilla Firefox. Firefox. So the Firefox makes it really easy, to use. So I'm gonna instead use Firefox for my development here. I will close this for now. Yeah, I'll keep it like that. So let's come to Explorer or Solana.com and check this out. When I click on custom explorer, you can see that it's working. Everything is showing the way it's supposed to be. All right, so when I click on add my RPC, my program code address, you can see that it's showing me information about the program. You can see all the transactions that was done, in the project. In this program. I wonder how many transactions was done there, but all of them were done today. Multiple deployment. That I have to deploy this like about 4 times already. So trying to test it out. So there we have it. Please take note of that difference, that Mozilla Firefox difference. It could really save you a lot of time and effort. So there we have it. So in the next part of this tutorial, we'll start building out every angle of this project, one step at a time. Come to this place. So we'll start with the header. This button doesn't work, so we're going to work on it, and then the rest of the application will follow suit. See you next. So let's come back to our code. I'm going to close this. So the first thing I want to do is come to this SRC here, and inside this component, I should remove it since I wasn't using it anyway. I think I should close this one. Okay, so let's work on this place. Okay, so the first thing we want to do is right here, we want to create a provider. Want to wrap our application with Solana provision. Okay, so this provider will help us to interact with the Solana ecosystem. So it will make our application have access to the Phantom wallet, and then be able to make interaction, with interaction to the Solana blockchain as well. So this is very important that we have it. And of course, this component requires that since you're using Next.js, you need to be making sure that your components are having these use clients. Okay, otherwise it complains, because Next.js is not just it's not a front-end programming framework, it's a full stack framework. So there's a difference between server-side rendering and client-side rendering. So if you don't follow that client-side rendering code that has to do with the client-side, and you making sure you mark it with client-side, it kind of produces some errors. And of course, you want to make a component. So we're going to call this component const app wallet provider, basically the same name as this. We can just say, since it's a React component, so we can say rfc. Okay, so this kind of populates some React code for me. So it's a handy tool. It's one of the extensions that you can easily check out. Where is it? This extension called ES7 React Redux React Native Snippet. Okay, so it helps you to do that. And now we have this. So inside here, the first thing we want to do is call on this component called connection provider. Okay, and it doesn't give me any suggestion, but connection provider is coming from Solana adapter. So if I do, let me search for package.json, I'll bring it to this angle. So we have Solana adapter wallet. So it is coming from this package right here. So let's have that included. Adapter React, this one. They're just named so similar. So see, import this a module from this location. So we say the name of the module is connection provider, like you can see here. So, and this connection provider takes in an endpoint. Okay, this endpoint, we can get it by saying const network is equal to call on this thing called wallet adapter network. So it's coming from this base. All right, and then you want to call dot, colon dot, you can say devnet. Okay, it will not matter much, and then you say const endpoint is equal to, we're going to put this endpoint in the memo, use memo. So for want to memorize it, we call on cluster. Okay, cluster API URL. So it's coming from Solana Web3. So you call on that cluster, and you want to pass in this network that you just added. And you also want to make that a dependency, because this use memo also function very similar to how use effect works. Use effect does have a callback function and a dependency array. So this is dependent on the network. Okay, so if the network changes, it also in the endpoint should also change. So that's what it's saying in essence. So now want to make sure that this is available here, and you need to also pass in a child into it. So we need this wallet provider now. Wallet provider is coming from this it's coming from this place, the same place as, I could close this now, same place as this wallet adapter React. Okay, so it's coming the same place as the connection provider, and this one takes in a prop called wallet, and this wallet, you're defining the kind of wallet providers that you should have. Okay, so for this one I only have Phantom here, but other than Phantom I could also use other ones as well, such as Solace and so on. So let's have that brought in here. So how you do that is say const wallet. You also want to memorize it. Okay, this use memo is very important for saving computation resources. So for example, if it helps you to store up value and not recompute that value except something change about, for example, except this network change, the value of this cluster will always remain the same. So it will not be consuming that memory resources again or computing resources. So it helps for efficiency management, to make it more efficient. Okay, to make the code more efficient. That's what use memo does in React. So I want to say this. Okay, so now we want to list the various wallets that we're going to need. So we're going to need Phantom wallet. So Phantom wallet adapter is going to be coming from this Solana. If I come here again, Solana wallet. Okay, so we're going to be getting it from the Solana wallet. So we say import from, so we say Phantom wallet adapter. Okay, we also want Solace, Flare wallet adapter. That there is so many of them which you can find in that one place. Let's check out. So which one do we have here? There's so many. This is Flare. There is Coinbase. I don't think I've seen. This is Phantom here. So all of these are various wallets, providers that this package supports. Okay, so we're going to need those two. So Phantom wallet provider, and you want to initialize that. You also want this Flare wallet adapter. So those are the various wallet adapters we're going to need. So after you have this, you can then pass in, you need to also make sure that it has dependency on network as well. So when network changes, it should change. Okay, so he's saying that it's unnecessary, but let's keep it that way. Okay, so I'm going to pass in this wallet in here. Okay, and of course this is going to request a child again. So this time around we need wallet modal. This wallet modal comes from the UI. Okay, we have this one called Solana wallet adapter React UI. So we need to make sure that we import that from that location. We say import something from here. So what are we importing? Want to import wallet modal provider. So this is what we're using here. Okay, and this one we only need children. Okay, we need to pass in the children. So because we're going to be wrapping this around our application, so how you get that children is by saying children here, but you need to define its type, because it's a prop. So you need to define children to be of this React node. Okay, so now we can pass in children here. Okay, so we're almost done. You also need to make sure that you have that Solana, the UI, this UI, right? So this Solana has its own UI system for the modal and the wallet thing. All of them, they have their own UI. So you need to make sure that you're importing the CSS that is being used there. So those are all that you're going to need for now. So you can save this. Okay, then you come to the main application here, not this page, but the layout itself. So we're going to come to the layout and we'll wrap all these things, under that application app wallet provider. So I'm going to wrap it all here. So there we go. When you save that, you want to check on the browser to see if everything is working. So everything seems to be working. You also want to check the console. So it's talking about these dummy keys. Don't worry about that. We'll later work on those ones. But for now, everything seems okay. Now we want to be able to connect our wallet. And to do that, let's work on the header component. Okay, in the header component, you need to call it header. The header component is just in the same page. This is where just some dummy stuff that we used. So let's make something not dummy. First of all, is mounted is going to be false. We're going to use a use effect. Okay, everything seems all right. So, but for this place, this button is going to be different altogether. We want to use a button that comes with Solana. So the button is called wallet multi button. Wallet multi button is coming from Solana. So wallet multi button, this is what it's talking about. So when we save that, let's check it out. You can see the button right here, right? That is cool, but we want to customize the button a little bit more by giving it some style, background color, and so want it to have a background color of this and text color of that. So if we come here, this is what it currently looks like. So if I save this, it doesn't make any much difference though, but let's test it out now. Let's click connect. You can see that is connected. So if I click on this, you can see this is the modal and this is how the modal looks. It will be able to tell you the various options. You can see Souffle is also there, but it's not available here. This is the one that is detected, which is this phantom, and I connect to it. Yeah, so you get connected. So that is it for setting up the wallet adapter for Solana. So in the next part of this, I think it's time for us to make sure that all these things are reduxified. Okay, we want to set up Redux so that whenever we do something, we can, it can be reflecting at real time. All right, so I'll see you in the next part of this video. So now to work with, I'm gonna close all this. So now to work with what's it called, Redux, we already have all the package installed here. You can see this React Redux and these at Redux toolkit. And in case you're wondering, this Toastify, we've already configured it, so it's currently right here. I mean, if you check this, you can see the work of Toastify. For example, if I vote here, you can see this is just the dummy stuff, so there is nothing happening. Okay, so I already have Toastify set up and all that. So let's set up let us set up the store, which is the Redux. To do that, I am going to create a new file. The name of this file is going to be called it's going to be in a folder called store, and inside that folder I'm going to have states, and inside that state I'm going to have global states.ts. So this is the name of my this is the file that is going to hold all the states that we want to put on one bucket here. So I would say export const, and it's going to be called global, and you have, now I want to show you something. Look at this utils folder. We have different interfaces. Okay, so I created these interfaces which are just types. So this interface, for example, we hold candidate information. So a candidate, this will be the PDA, public key, basically the the program derived address for each candidate per candidate. This is the candidate ID, this is the poll ID, this is the name of the candidate, this is the number of votes, and this is the registration status of that candidate. You can see this is also the program derived address for a poll, and this is the ID of the poll, the description of the poll, the time you start, the end time, and the number of candidates it has. Now we are bundling all these things in an interface called global state. So a global state is going to have number of poll, and a poll can have value or can be null. And we have candidates, which is going to hold an array of candidates, which is this here, and this is going to hold voters, which is basically an array of any. Okay, I don't think I actually made use of this voters, so this voters is not really going to be necessary for this development. Okay, because we don't need to expressively grab all the voters, so I'm going to remove it. And also we have registration modal, which help us to invoke registrations modal or exit it out. So that is needed. And I'm also bundling it again in this root state, which is going to be useful later on when we're working on this project. So I'm going to save this, and then I come here. This global state is going to be of a type called global state. Is coming from this utility, our global state. This interface is here. So this is going to be made up of, you see, if you don't put the right information, it's going to complain. So it's going to be made up of candidates, and a candidate by default is an empty array. It's going to be made up of a poll. By default, a poll is a null value. It's going to be made up of this reg modal. By default, the scale is going to be 0. So those are the basic things you need to know about the state. Now I'm going to create an action that will regulate or modify these information, and to do that you need to come here to new and say global actions.ts, but you want to put it in this actions folder. All right, so sorry, it must be inside this. Close this first, bring it in here. So yeah, it should be on a separate folder, not inside the state. So inside here we want to say export const global, not state, but global actions, and it's going to contain these mutation functions. Okay, so they are called actions. For example, we want to be able to set candidates, and the reason why we want to make candidate to be in the store is because when we vote, we want to be able to modify the content of candidate without refreshing the page. When we register a new candidate, we want it to update without refreshing the page. So those activities calls for us to have this on the bucket. And now so what is going to be needed here is going to be state. So the state is going to be state is going to be global state. You want to grab it here. Okay, and the action is going to be payload. This payload is coming from payload action. This one is coming from Redux toolkit, so I'm going to import it from Redux toolkit. So I'm going to get this payload action. So this payload action. All right, at this point, you want to say this state dot candidates. So you can even, let's say, call it state. So we say this state dot candidates. You want to set it with what you're getting from this action dot the payload that you're receiving. So now you need to specify what kind of payload, what is the content of this payload, because this is TypeScript. Everything has to be in alignment, so you need to typecast it to say candidates, but that you're setting an array because this global state is based on an array, so you need to make sure it's an array of candidates. All right, so there we have it. And you want to do the same for setting of pool. Okay, you want to say set pool and a single poll basically, and you want to call this poll. That is what we're setting in here, and you want to call this dot poll, and you need to import this interface as well, so we have it here. And lastly, you want to set the registration modal, reg modal, and this is going to be a string this time, and you want to call on this reg modal, save it. So those are the actions that you're going to need. Now we need to bundle all this action and state inside something called a slice. Okay, so in the slice, let's create a new file, call it I don't know why VS Code is having these issues of whenever I want to create a new file, it just try to do so and then disappear. It's just very annoying. So I'm going to copy this. Let me see if I can copy this action, paste it in the store folder. After doing that, and I will rename this to, see, it's also misbehaving with renaming, call it global slices. Okay, so now inside these global slices, I'm going to remove all this. I wasn't supposed to have them in the first place. Make sure that I'm exporting global slices, and now let's modify this. So a slice is based on this thing called create slice, and it's coming from this Redux toolkit. Okay, and if you want to create a slice, you will need a name for that slice, and we want to call this one global. And you also need an initial state. So initial state is going to be that global state. So I want to say global state now. So, and I want to give it an alias as global state, but I want to capitalize this. So I'm going to call this global state. And I also want reducers. Reducers are basically those actions that you're going to be modifying. So I'm going to call that one global actions. So say global actions. And now I'm also going to be giving it an alias as well as global actions. Give it a capital. Okay, so now this is it. I would like to export two things. One is this const global actions. Okay, this is exactly why I gave it an alias, because if I don't give it an alias and I'm using it here and I imported it and I want to export it as well, it doesn't make any sense and it was going to give me an error. So I'm going to say global action is going to be this global slices dot actions, and then I want to export something as default, default, call it global slices dot reducers. Okay, so please pay attention again. If I do this, if I remove this action and then try to use it here, it's going to give an error because I'm trying to export what I imported and it doesn't work that way. That is why I gave it this alias. And now this doesn't apply to this because I could do this, I could do this way and say global slice and everything works well. But just to make sure that it conforms to the same pattern, I decided to keep it this way. Okay, so now I have this reducer all set up. The next thing I want to do is to have my index, my bundle everything in one place. So I'm going to call this a new file. Say I could duplicate this, I could duplicate this. I'll copy this and paste it here, and I will rename this to index.ts. So in this index, I'm going to remove all this. I will say export const store. So in the store, I'm going to invoke this config store that is coming from Redux. So this is how we configure the store, and I'll also apply the reducers. The reducer is basically a global slice. So we'll say global state is going to be what is global slices. Yep, sorry, it shouldn't be imported this way. It should be imported this way instead. Okay, so I have global slice and everything is set now. Now we want to wrap it up in our application. Right now in our application, I don't think I'm going to use this. Let me open a new, let me launch this. I don't have this plugin right here, this dev tool on. So this is the state before I even there is no state here in this application. Anything that is here is not based on what I'm working on. Okay, so I'm going to set it up and then come back to it. So if I come here, I will wrap it around my application again, just like I did with this app wallet provider. So I will come here, say provider, this one is coming from a different place. This provider, come here and say import from React Redux. This time around we want to import provider. So this provider is coming from there, and I'm gonna shift this into it, and it need a store. Okay, the store is this index right here. So that's what we want. So I'm going to import that store. Okay, you can see it's coming from this same location, the homepage there. So we have the store added there and we are good to go. So let's save that and come here. When I check this place now, you can see this is the global state. You can see the candidate has, an empty an empty array, the poll is null, and then the registration modal is just scaled down to 0. So for now, that is all we need to do consigning. So we'll set up our store, we'll set up every single thing that we're going to need. So in the next part of this video, we are going to be creating a new poll. All right, so I'll see you in the next part of this video. Okay, so this is the create page. You can easily come there by clicking on this button. So when we check it out on, I'm going to close all this. When we check it out on this page, come to create page. Okay, here we are. So what basically happened is just a drop. You understand that? A short simulation and a drop of whatever we're doing. So let's work on that. I'm going to create this for now. Say best sport in the world. Say started yesterday. One thing I don't like Mozilla is because it doesn't provide me this date time enablement here, unlike with the other one, Brave. So I have to manually enter it. So it ends here. Let me just show you what is going on. If I click create, this is what we get. Okay, so this is what we'll be sending into the smart contract. Of course, this number has to be represented in a big integer format. So this is what is happening right now. Now all this is sending, but then we need to send this somewhere. Okay, we need to send it somewhere. That place, we want to create a special service or folder that we be responsible for handling all those procedures. Okay, this is more like my pattern, my way of having a service that we handle all the processes, but from there I'll be calling that service. It just makes sense a lot, than scattering the code that has to do with the blockchain all over the place. It's not very maintainable that way. So I'm going to create a new folder. I'll call it services/blockchain. Let's just call it blockchain.ts. Okay, so we have this folder and we have this file, and inside this file we'll have many endpoints that we'll be calling. It's basically just providing like an endpoint for our application. So let's take it one step at a time. For we to be able to interact with the blockchain, we need to get to create a function called getProvider. Okay, the provider is what gives you the ability to communicate or to talk to the blockchain. It's more like a telecom provider. Without a provider, you cannot, talk online. So this is going to be a function. So this is the skeleton of the function. And now this provider is going to take some information, such as we're going to need a public key. It's going to be of a type public key that comes from Solana Web3. Okay, and it can also be null. So we're also going to need a signer. We also need a signed transaction and a send transaction. These two we're going to pass it in, keep it as any. All right, at the end of the day, it should return a promise, and this promise should be based on a type called votee. This votee is going to be coming from this anchor. Check target, check type. You see this is the votee. This is the type that we want to work, because this type provides us all the information that has to do with our smart contract in TypeScript. Okay, so interface. So we'll call it vote, and it's coming from, we need to make sure we specify that location very well. So we say import something from, say da-da-da, and then you go to anchor, then you go to target, then you go to types, and you import this here. So what we're grabbing from this place is this thing called vote. So, and if I check it out, if you see, you can see all the information that has to do with our contract. You can see our contract address. You can see that is basically program address. You can see information about if all the things that you need basically are all there. Okay, so we're gonna have to return a promise, a provider that is based on this vote structure. Okay, it can be that, but it can also be null, because okay, so it can also be null. Okay, so the first thing we want to check here is if there is no public key. If there is no public key, or if there is no signed transaction, okay, then it should report this error saying, so we're logging this error saying wallet not connected, because I'm going to have like two kinds of provider. One is going to be a read-only provider. One will be a read-write provider. Okay, a read-only provider enables me to retrieve stuff from the blockchain, read data from the blockchain, without needing to connect my wallet address first. So I could do a lot using that means. But a write operation will require that the provider I'm talking to has the ability to write or send transaction to the blockchain, which is where our wallet provider comes in. So that will come in, but for now, let's just focus on this get provider. I'm going to show you read-only provider. Missing signed transaction. Okay, and after that you return null. Okay, so this is the instance where we can return null. Otherwise, if that was successful, then we want to get the connection. Const connection. Connection is going to be based on new connection, and it's coming from Solana Web3. And now the connection, you need to pass in the endpoint, the URL that you're communicating. Remember if we go back to the C code.env, this is the URL, this RPC URL that we want to speak with. So but before we do that, we need to grab it here first. So we say const, RPC URL, which has to be a string. It's going to be this process dot this environment dot this NextJs this environment variable. Or if that didn't work out, we want to just provide a default URL, which is this here. Okay, so and now we can pass this in here, and I want a commitment level of finalized. So that is what we're dealing with. So we got that. We can use let's use we can use confirmed, we can use finalized. Doesn't really matter much here. So the next thing we want to do is const provider is equal to a new anchor provider, and this one is coming from this Coral XYZ / Anchor. So this is where that provider is coming from, Anchor provider. And in Anchor provider, we're going to pass some essential information. First of all, we'll pass that connection. If you look here, it has connection, the wallet, and some optional values. So connection, that's the first one. And we also need to pass in the wallet. So this is going to be how the wallet be. So the wallet involves this public key, this sign transaction, okay, and this send transaction. Okay, now you want to get this as unknown. If I say as wallet, it's going to give me an issue, so I'll say as unknown first and then as wallet, and that, kind of wrap it up. Then we also need to pass in the commitment level. Okay, so say commitment, say finalized. Okay, so this is the provider. Now we need to return this provider. It's a new program. This program too is coming from this location. That Coral, this what's it called? Coral XYZ Anchor. You understand that? So I'm passing the provider, but I'm going to type and then passing this ideal. I need to get an ideal. Okay, the ideal is basically like the ABI, and here is where you find the ideal. Here, ideal, you see, this gives you information about the structure of these smart contract. Okay, so it has all the information that you need to create or to interact with the smart contract. So it's more like an ABI if you're working with Solidity. So I'll come here and say import IDL from, and then I go back to and then go to Anchor, go to target /IDL, and then grab this. At this point you can see it has all those information, so I'm going to pass that IDL here. Okay, and I also want to pass in this provider that we just got here, but this idea you want to pass it as any. Okay, and you know that you're supposed to return a promise that is based on this type, right? So I'm going to typecast this program with that votee. Sorry, I'm not supposed to return a promise based, but a program. That is what I'm supposed to return, a program. Okay, so this provider returns a program, and this is the program we're returning. So at this point, we can use this program to write another. We'll use that to write to first of all initialize this application. Remember, we did have various functions. Let me say lib. So if you come to this place, you find out that before you even can create poll, you need to be able to initialize the program first. This is one of the reasons I like Solidity, because it kind of gives you this constructor that executes on its own whenever you start up that project. The smart contract is deployed on the internet, so on the blockchain. So we're going to have to write a function first to help us initialize our registration and counter variables. So we say export const initialize. So it's going to be asynchronous in nature, and this is a basic structure of a function. So now, of course, just similar to this, is going to require program. Okay, the program is going to be based on this program and a type cast of votee. Okay, we're going to need that, and we need a public key. It's going to be based on the public key. Okay, those are the two things we need, and it's going to return a promise that is based on transaction signature. Okay, so transaction signature is coming from this Solana Web3. All right, so that is what we need to create it. So, but before we can create, we're going to need to create initialize the counter. Okay, counter PDA. So we need to create one. So it's a const. We do this. Say public key dot find, find program address sync. Okay, and inside here we want a buffer. Remember, this is how we form our PDA. Okay, so this is what we're basically doing. So we're forming a PDA for getting the counter information. Okay, so say from, and the keyword here is going to be counter, and of course we need to pass in a program ID. Now this program ID we've not created it, and how we do it is quite simple. So you come above here, it's a const program ID is equal to, say, new public key, and this public key is going to be based on this IDL. Okay, equal on this dot address. This dot address is going to give you the address of the program. All right, so this will give us the public key. Okay, so we can say public key. All right, so we can then utilize that here. So this is where the public key comes in. After that, well, this can be called counter PDA. Counter PDA. And then you want to also do the registration PDA, because when we are initializing, we're not only initializing, let's initialize, this is an instruction. So we initializing the counter, and we're also initializing the registration counter as well. You can see this is the seed for the counter which we just supplied, and this is the seed for the registrations. Okay, so you want those two information. So I'm going to do this for this one. I'll call this registration PDA. Okay, so I got those two PDAs. So these things are public keys. This PDA and this one, they are both public keys. You should take note of that. Now that we have that, you want to create a new variable here, because we're going to be using it quite a lot. So we say tx, and it's type of any. So we want to form a transaction. Say await program. We're calling on that program. We initialize. We're calling on the program that we got here. Program. Okay. You call on dot methods, and then you call on this initialize method, and you call on this account is there's a account partials. That's what we're using. Account partials. All right, and hope I'm spelling that correct. Account partials. Okay, account partials. Okay, I thought I missed something. And you see it contains user, account partial, then the .ropc. So user is going to be the public key that we got here. Here, this is the user, and the counter is going to be the counter PDA. The registration is going to be this registration PDA, and the system program is going to be this system program dot program ID. Okay, so the reason why I'm having this little error here is because this is supposed to be a function and it's supposed to be in this format. So you see this error is gone. And now I need to make sure that I store this in a variable, because at this point I want to wait out till this transaction is completed. If this transaction isn't completed, I don't want this to be over, because why I've come to understand that, if you want to have that feel and real-time effect, like like you're working with Redux, okay, you need to make sure that you wait out that something is completed. Otherwise, if I perform a transaction, I didn't wait for it to be completed, then to be finalized, then even though I refresh, that procedure will not yet reflect until it is confirmed on the blockchain. That process is quite I don't want that to be so. So that's what I'm going to do. I'm going to get this connection again, const connection, and the connection is going to be a new connection like before. And how do I get the URL? Say program dot provider, and then I'm calling on the connection. I'm also calling on the RPC endpoint. So the RPC endpoint, whatever endpoint that I'm working in, if it is localhost, if it is test node or testnet, or if it is devnet or mainnet, any one of them will show up here. And then the commitment level, I want it to be finalized, because finalized state means that this thing is perfected, is on a blockchain, and when I'm refreshing, I'm going to get that. So it's a sure way to make sure that works out. So I want to say await this connection now that I formed. I want to wait on confirmation, confirm transaction. Okay, so what am I trying to confirm? This transaction above, and the status is finalization. Okay, so we can also say, we can just say this one for now, say this one can be confirmed, but this one here, this one is the one that is so important. This one has to be finalized before. So once this is finalized, then it will release this function to return the transaction information to us. So this is what we are intending on executing. So now that I have this function, I need to initialize that function first before I even try creating anything. Otherwise, I will not be able to create anything. That was the first thing I'm supposed to do. So we will then have to come to this page. Okay, so you see these things here. We're going to work on it a little bit. So right here, we're going to write a function, call it const handle init. So this function will be responsible for handling initialization. And now the way this is set up is that if there is no poll, it should, okay, so it should just say list out. So if there is nothing, say we don't have any polls yet, be the first to create one. Okay, so that's this condition here. So this condition says if it is initialized and the poll length is greater than 0, then it should list out some things, and the initialization is true by default. So, but if it isn't initialized, what about, let's say, false? So if it's not initialized, what happens this time? You see, we have a button called initialize. If it is initialized and we have a public key, okay, this time, well, what if we don't have a public key? It says what? We do not have any public key. We don't have any poll here. Please connect wallet, because there is no public key available. So we first need to get that public key. Make sure that the public key is exactly how it's supposed to be, And how you get the public key is from this thing called, I'm going to comment out this line, then I will say const use wallet. Okay, so in this use wallet here, I could call on this public key. Okay, so this is how I know that the public key is connected or not connected. When I save that, you see it's not connected, or if I connect now, you can see that it has switched. This is what I'm trying to get into. So we now have this initialization button here. Okay, so at this point we want to attach this button to this one called if the program is not initialized and there is a public key, then we should initialize it by saying handle init. So we're going to do that, but there is nothing in this function yet, so we're going to have to work on it. So the first thing you want to do, you want to make sure that the function, is not already initialized. Okay, we've not already initialized, because initialization can only be called once. We don't need to call initialization more than once. So we're doing that. I want to make sure that public key is not null. So that means there is, if you want to make sure that the public key is connected, the wallet is connected. Okay, so once that is a reality, then I want to call on this await. We use this toastify. It has this method called promise. It's used to show progress or indication that a blockchain transaction is up and running. So it's just that notification thing that I've been showing you before. So in this place, this require two things. The first thing it's going to require is a promise. So it's a new promise. Now in this new promise, it's going to return void, and it's going to be a synchronous promise as well, and it has resolve and reject. Okay, so this is the first component of this, and also it will require a status indication. So the status can either be pending, pending, approve, pending, success, or error. Okay, so those are the various criteria. I think I may be making a little bit of a mistake here, so I'm gonna remove this here. It's not supposed to be here, but here. Okay, so now let us work on this content. So we want to try catch. So if there is any error, we just want to log out that error. Okay, so if there is any error, I want to say transaction failed with this error. But if there is no error, then first of all, I want to call on that. Say tx is going to be, we'll call on this await initialize. Okay, this initialize that is coming from the blockchain. Okay, so we import that, and then we'll pass in the information that is needed to be passed. Okay, so we will need to grab the program. Remember, we need the program. We already have the public key, but we don't yet have the program. And let's say const program, and this program, we want to memorize it. What it's supposed to be is get provider that we created in the blockchain service, and you pass in the public key here. Okay, and you pass in that signed transaction. All this we need to get it from here as well. Send transaction and sign transaction. So we need to pass in sign transaction, and also we need to pass in send transaction. Okay, so this is how it's supposed to be, but because we don't want this to be a reoccurring stuff, we want it to be memorized, with the value, present, and defined without it recomputing all the time. We need to put it in a memo, okay? Use memo. So how we do that is say use memo, and we do this. Okay, so here we go. So at this point, we want to also make this dependency in the dependency array. So this we grab this get provider, and only we change if any one of these things is changing. Okay, so this is the program, and then I'm going to pass in the program. I'm also going to guarantee this initialize function that this program is never going to be null. Okay, so that's why I'm putting that exclamation mark behind, and also going to be passing this public key and saying that it's not going to be null. Okay, so when I pass those two, I can then proceed. First of all, I want to log off this transaction, say tx. After it's done, after I've logged that, then I can resolve, say tx, but I need to cast it as any. Okay, so when you do this, then you only have to execute that one. So okay, this is also very important. This is one angle of it. There's also another angle that we need to fetch the status. We need to know whether this has been initialized, because right now we are actually hard coding this false thing. We need to get the status freshly from the blockchain itself and determine whether or not these these counters have been initialized. Okay, and to do that, we need to come back to our blockchain service. Inside our blockchain service, we want to create another function called export const get counter. Okay, and it's going to be an asynchronous function, and this is the skeleton of the function. Now this function is going to need a program, like always. Okay, type of VOT, and it's also, that's all we need, and it has to return a promise that is based on this bn. This bn is coming from this Cora. So this is basically this is supposed to be a anchor's version of big integer. Okay, something like that, but it's a data type. Okay, so that is what it's supposed to return. This is what we are expecting, and we need a try catch, of course. And if there is any error, okay, remember I want to return this body, this type of data, this data type. Okay, so now remember here that when you're initializing, the default value of this counter is supposed to be 0 or anything greater, but it cannot be less than 0. So I'm saying here is that what I'm saying is, if it call on this get counter and it produces any error, that means the error will indicate that it cannot retrieve the status of that counter because it has not been initialized. Then it should return -1. That will give me an indication that these particular counters have not been initialized, have not executed them. So that is for a failure situation. But if there is no failure situation, I want to get the counter PDA. Okay, great. And I want to call on the counter. So I'll say const counter is now equal to await this program, and then dot call on the account, call on the counter. You see that we have both counter, we have registration, but we want to call on the counter, and we want to fetch. So we want to fetch based on this address. The address is going to be the PDA, okay, this program derived address. So we'll fetch this counter, and after we fetch it, we want to do if there is no counter, then it should return 0 for us. So we want to return 0 this time. Return instead of returning. Okay, we want to return 0. You can return 0 or return -1, because that will mean that it is not found. Because if everything is okay, it should return 0 for us. We don't need to, tell it to do the right thing. So we can say, it should return a warning along saying no counter found, returning 0. So it can't find a counter, should just return -1. Okay, otherwise it should return a counter.count. Okay, so this alone, we don't need to do for both registration and counter, because we are very sure that if counter was successfully initialized, that means the registration is also successfully initialized, because both of them are executed in the same function in the blockchain. So this will help us to get the current state of the counter. When I save this and then come here, I will not need to do this manually, so I have to do it using a dynamic structure. And now we can call that fetch data. Okay, so let's create a function here. So const fetch data, and in fetching data, this is going to be a synchronous function. This is structure, and we are not going to need any parameter. We're just going to say const count, okay, is equal to await, say get counter. It's coming from the blockchain as well. In this get counter, you see, for this particular one, we cannot use this program. We want to use another kind of a program that has a different requirement, a read-only program. This program here only requires that I have my wallet connected. If my wallet is not connected, then it will not work, it will fail. And that will kind of mess up things for us when other people that are just visiting our website without needing to first connect their wallet address, then it will be giving them error. We don't need that. So we need to also create a provider that is going to be read-only. Okay, a read-only provider, and this is how we do it. It's quite similar to how we did the other one. So I'm going to come here, and we're going to have to just duplicate this. Okay, so get read-only provider. And now when you're getting a read-only provider, you will not need any one of these requirements. Okay, you won't need any one of them, and you're sure that you're going to only return this. So we don't need this first if else statement, and we can just put these ones to be commitment level to be confirmed. Meanwhile, this one can be commitment level here, can be processed. Okay, this one doesn't, these ones don't affect what we are doing. Okay, so long as at this point we are doing this here, we are ensuring that this is final, this transaction is finalized here, then we're good to go. So first of all, we want to use a dummy wallet address, okay, because you can't make communication to that blockchain without a public key. You understand that? So, but this public key, since we're not writing, we're only reading, it doesn't need to be some serious one. It just have to be a public key, a legit public key. So we're going to say here that const wallet is equal to, we'll create the element of wallet. So wallet need a public key, okay, and the public key is going to be this public that is coming from Anchor, and then say dot default. It does have a default key, okay. This default key value, okay, represent a string So basically it returns you a default key. Basically that is what it does. And you want to pass in this sign transaction. Okay, it's going to be an asynchronous function. Okay, that will just throw an error. Okay, so this is the error that is throwing, saying new error, read-only provider cannot sign transaction. Okay, and we also need another one called sign all transaction. So that we can just duplicate this. Okay, so read-only cannot sign transactions either. So this is the wallet, right? And now we can use that wallet to create a provider. So this is the wallet that we used before. So in this case now, we just need to pass in this wallet now. Okay, we can just pass that wallet and we're good to go. Okay, we can, that is all we need to do. That is the modification. So you save that, and in this place we're going to duplicate this. I'm going to call this program read only. So this is read only program, and for this program we will not need all this. We'll say get read only provider. You need to import that, and you need to remove all this from the dependency array since it doesn't need it. Okay, so this is the program that we want to use here, and we'll pass in this program here, and that is all we need to pass in. Okay, when we pass in that program, we'll be able to get the counter, and when the counter returns, we need to say set. Okay, now instead of having this way, we're going to use state. Say is, and then you say this set is, and then it's gonna be a boolean. So use state, say boolean, and by default it should be false. Okay, now we can say set initialize, and initialize should be this count dot, is it greater than or equal to 0? Okay, this is how you check for 0. You call on this bn, need to import it as well, but we'll do that bn, and then you pass in 0. You want to check if it is equal to that, but of course this is where that record is, so I need to remove this. Okay, so when this is checked, if it is zero, greater than or equal to 0, it's going to return true that this has been initialized. But if it is less than 0, which is that -1, it's going to show that okay, this has not been initialized, so that button can be opened for us. But now we need to make sure that there is a use effect that is executing this function on the start of this program. So we say use effect, and okay, so use effect is called by function. Before we even go ahead, we want to make sure that program read only is not empty. Okay, it's not null. If it is, we should just return. Otherwise, you fetch that data. Okay, and this program read only is a dependency. For now, let's save that and watch this. So now I've not connected my wallet, right? So let me connect my wallet. You can see I connected my wallet. Let me refresh again. This is not staying. Okay, so we missed out something very important. And why the reason why this was not automatically connecting whenever we restart our application, because we missed out this essential prop called auto connect, which was supposed to help our application recover its connection whenever we refresh. So with that, resolved, let's just monitor this. Okay, so you can see here when we're checking for counter, you can see that there is no counter found yet. You can see it's saying that account does not exist or has no data for this. Okay, so there's no counter yet. Now let's initialize. Says system program is not defined. What happened? We had skipped this essential information. Close here. Where is that system program? We need to import the system program. Okay, and it's coming from Web3, Solana Web3. So it is here now. So let's save that and come back. Now let's initialize that. You can see this is the reason why we needed to add that Toastify. And since we are working with localhost right here, but let's cancel this for now. We'll come back. Let's make sure that this is in localhost connection. So this is not localhost, this is Devnet. So let's make sure that you go to your wallet. Click on this setting gear, and come to this developer settings. Go to this Solana and choose local, net. All right. So when you do that, you come back, close this, and then you click on initialize again. And this time it normally will take some time because of local net. There's some issues about this, and it's going to say that this is may fail. You say confirm anyway, and you're waiting for the approval. Once it is approved, you should be able to see the transaction record printed here. So remember, we're waiting for it to be finalized. Finalization is what we're targeting. You can see that it's been finalized, and this has been successful now. Okay, so when we save this, the reason why this did not automatically toggle was because we missed out this essential information. So when we come here at this point, after it was successful, we were supposed to fetch data here. We need to call that again. Okay, so by calling it, it will grab the latest one and get this thing resolved. You can see that this thing is no longer there, and it's saying that be the first to create, not connect wallet again. Okay, so we can copy this. Okay, we can copy this address and say let's check for it here. And before that, you want to first refresh this. So you see a minute ago there was a transaction that happened here, which is basically this transaction that I just executed. You can see what is going on here. If you come to the bottom, you can see that the log is saying that instruction initialize. So we're calling on that initialization function, and it's quite successful. So at this point, we've been able to initialize this project or the program. Maybe you can design it in such a way that when you're deploying this smart contract, you can also execute a function that we go and initialize this at the background without waiting for users to initialize it themselves. So it is good that since this is for learning purposes, there's no issues there. We can always learn from that and make it a lot much better. So that is what it is for this particular part. In the next part, we're going to now have to create, since we've successfully initialized our function, our program. So I will see you next. So since we've been able to do, we now have the ability we've been able to initialize the program. The next thing we want to do is to create polls. We are able to create polls. Now we already have a function that will help us to collect those information about a poll. So at this point, all we need now is another function in the blockchain that will enable us to create the pool. And this is how we do it. Can close this. Whenever you want a read-only function, you call this a read-only provider. Use this. Read-write, you call this. So that is what you're going to be doing. So at this point, we want to create another function. Okay, this function is going to be called create pool, and these are the information it's going to need. Just like with this, we're going to need a program and the public key. Not only that, we want, remember we had this idea of a counter it gives you access into what the next program ID, what to predict the next program ID. Remember that. So we had that ability to determine which is going to be the next program ID. So we need something like next counter. Next count is going to be a BN, of course, type, and of course it's going to need a description that gives, which is a string. We use that to create the name of the poll or the details of the poll. We need a start time. Okay, so start is a number. We need the end time, which is also a number. So these are records that we use in creating a poll, and we need a transaction signature as what we are expecting at the end. So that needs to be what we return. Okay, so the first thing you want to do is to get both. You want to get this counter PDA. So we're going to use that. Okay, so we have that. Now what else do we want? We want a poll PDA. Okay, a poll PDA. And most of this thing that I'm doing, if you were part of our tutorial when we were doing the testing, okay, you find out that we had all these things set up already. So you can see, for example, this is you now predicting the next count, which is already there. And this is how this information here, this is how you determine, the seed, the PDA. Okay, this is how you derive you get a poll program derived address. Okay, the address of a poll. So it's going to be based on, first of all, you need to convert this key, this next count into this format. Okay, this little endian, and we need to convert that. So how we do that is we say this next count, say dot to array like. Okay, and you say to array like, it's going to be buffer, just like you have here, and then you say comma le, and then it's going to be of length of 8 bits. Okay, so this gives you the program derived address. Okay, so for a poll. All right, so with that, then we need to have our start const, says start bn is going to be a new bn. We want to convert this start time into a bn format. Is a number at this point, but we want it to be in this format because this is the format that is going to be recognized when you're sending it to the blockchain. You also need the same thing for the end time here. Say end. Okay, so you need those. Great. Now we need to now call on that transaction, which is this. We can use this method. Copy this. Can close this now. See, transaction. We want to call on the create poll method, and in the create poll you need a description, because if we check here, a create poll needs a description. It needs a start. It needs a start time, and it needs an end time. You can see the type of the data type that it contains, you can see is a U64, which is integer, basically unsigned integer. So now let's pass that description. You pass in the start time, you pass in the start bn and end bn. Okay, so that resolves it. Okay, so it's complaining about this registration thing. It's not part of its requirement, so but poll is okay, and we use this poll PDA instead. Okay, so we have user counter, we have poll, and we have system program. So we have all those things completed. At this point, you can just copy this whole thing from here to here, because they are just about the same thing. And then you paste it here, and then that is it. You get the connection, and then you confirm that this transaction has been finalized. And once it is, you release that. So here we go, we save that, and we now come to this create page. So here we are in this create page. We need to change this dynamic a little bit. So I'm going to come here, copy something similar that I've already done here. See this whole thing? I'll copy it. This toastification method, I'll paste it here. Make sure that I import it, React Toastify. Okay, and also make sure that this is an asynchronous function. Then I'm going to make sure that before I even do any more thing, I want to make sure that if there is no program or this thing is not initialized, then it should return. So I'm doing something here. These are the criteria for me to be able to speak to the blockchain, and we've already done something similar like that here. You can see something similar like that, and for us to do the same thing here, we know that we will need this program. This is a program, not read-only, just this, because we're creating. So I'm going to get that program first here. Okay, and make sure that I import this memo, use memo, import this. Okay, so but these details are going to be coming from this point, this use wallet. So I'm going to copy that and paste it here. Make sure that I import use wallet. No, this is not where we're getting the provider. This provider is coming from this blockchain service. Okay, that is the right way. So this has been resolved, but this now remaining. To achieve that one, you will need to do something similar to this as well. So we're going to copy this line and paste here. Okay, so you see that has been resolved. But now we need a use effect. Okay, we need a use effect to make sure that this thing is grabbing details from the blockchain and we're not just thinking about it by our own self. Okay, so to do that, we come here, we say use effect. So in this use effect right here, we want a function called fetch counter. Okay, which is going to be an asynchronous function. And I think we can literally write that outside here. So this function here, I want to say if there is no program, it should just return. Otherwise, it's a count. You want to get count again, just like we did before here. So you can easily get that this way. Say count is equal to get counter. Grab that, from the and then you pass in this program. Okay. Then make sure you also import this. It is coming from this location, so you import that. Okay. So we set now, but there's one more thing. We need to set up to determine preemptively preemptively determine what the next PDA is going to be. So to do that, we want to say const, we say next count and set next count, okay, is equal to use state. And in this use state, we have a specific type that we'll use in this BN, and by default, it's not just going to be a 0 like this, but it's going to be new BN and 0. Okay, so this is the default value. Now for this place, you want to also set next count. Okay, so set next count is going to be this count, okay, plus add. All right, you add 1 to it, so it's a new BN, and then you add 1. So this gives you the next counter for the program. So it helps you to know which address is what is gonna be the next thing. Okay. So now you say fetch counter, and you want to make sure that it's dependent on this program and this form data. Okay, so this program and this form data, if those things they change, I don't think the form data is very important, because we'll type in things and it can, so we will need to put something else. We can do something like const is submitted, submitting, and we have set submitting. Okay, it's going to be a use state, and based on a Boolean value, default is false. Okay, so at this point, I also want it to be based on this submitting. Okay, so at this point, we want to set submitting to be true. Okay, so here we go. We initialize this, get it from the blockchain. We're not initializing, sorry. We are creating a poll, create poll from the blockchain. So we grab that create poll, and this create poll is going to need 6 arguments and not just 2. So we've added program, we've added public key. What else do we need? The next count. Okay, we've already included it there. Okay, and after the next count, we need a description. Okay, which are this information. A description. We also need a start time. So we have start time and we have an end time. So these are all these records that we take to create a poll. And this fetch data is not fetch data but fetch counter. So this is it, and if that is successful, if it is successful, it's going to be added to the blockchain. Okay, here should come. I want to remove this as well, but this we can do this way. All right, so we save that, and let's check it out on the browser. Refresh. Want to see, let's make sure we're inspecting this and see everything that is working. Want to say best field of education is another poll, started 24th and we end 30th. Okay, and then we'll click on create poll, so it's going to wait for approval. All right, so you confirm. The reason why this is misbehaving this way is because it's on localhost and it doesn't really have a lot of information. It's not as, this wallet is not as rich as MetaMask in this ability to detect the local connection, but it's just doing all right. We are managing and we're cool, we're going. So long as it's doing that job, we're fine. So we confirm that. So this is going to take a while. And and once it's confirmed, it should drop the details here. Okay, you can see that has been created, and you can even check this. If you look at it on the blockchain, you can see that is an instruction for creating a poll. So now we are able to create polls, and that is really awesome, really cool. And this is great. At this point, we then need to list out this poll. Okay, we need to list it out ourselves. Right now it's not being listed, so in the next part of this video, that is what we're trying to what we are going to tackle to make sure that you are seeing what you're creating on the fly. So I'll see you in the next part of this video. Okay, so to list out the posts that have been created on this platform, let me close from here, close this. We have to come back to the blockchain service and create another one, and this we're gonna call it fetch polls. Okay, so fetch all polls. Let's do that. So this is a function. It enables us to fetch all the polls on the platform. One of the things that you must be aware about, that I actually do like about Anchor and Solana in general, is the fact that when the functions that I've been creating, especially on the smart contract, I only was writing a write function, okay, but Solana by default provided me with some read functions as well. So for example, for every poll that I created, Solana provides me with a method that I can read or get all those polls without needing to go through hassles. And the same thing with the candidate. I could retrieve all the candidates, I could retrieve all the votes or voters that have casted their votes without me writing a single code on the smart contract again. So that is an added advantage. If it was Solidity, I would have to write both the read and the read functions and the write functions all by myself. So that kind of gives me some advantage. Okay, so what we're going to need here, like always, we're going to need the program ID, the programs first. We need that program. So I'm going to copy that part, bring it here. So need a program. Without the program, I can interact with the blockchain. Okay, so I will need a new key called poll address. This is the PDA, so we'll call it poll PDA. So basically, this is the address, of. I will just call it poll address. This is the location where this poll can be gotten from the blockchain. Okay, and I'm probably making a mistake here. This is for this particular session, I'm only going to need a program, only a program for me to fetch the poll. I'll come back later to deal with fetching a specific poll. Okay, so for now, let's look at that one. And we want to return a promise that is of a type of poll, but not just poll, but an array of polls. So I'm going to import this from the type interface. Okay, so what I need first is to get all my polls, and how I do that is saying await, and I grab this program. Okay, I call on the account and then the poll. These are various things that I could retrieve from the platform. I could retrieve the candidate, the counter, the poll, the registrations, the voters, but this time is the poll. And then I call on this .all. This .all method helps me to grab, all the polls. Okay, so call on that method, and I want to create another function. This is going to be called Serialize Poll. So I'm going to say const Serialize Polls, and for now let me put it this way. but this function is going to be a little bit different. So in serializing a poll, I will need to accept a poll, polls, okay, and it could be any, because when the poll is coming from the blockchain, the type is not really exactly the same with how it is in our if I should come here, it's not going to be exactly this way. So this is a modified version of it, so we want to make sure that it's any. So when the polls are coming from the blockchain, is any, we'll pass an array of any here. And then what we are expecting to pull out after serializing this is an array of polls, okay? Yeah, and at this point you want to immediately start looping through each one of those polls. So you can say polls.map, and we're going to map for every member, which is, let's just say C, which is any. We want to return an object, and this object will say C. This C, which is an object, okay, want to destructure it, and we'll say dot account. Want to bring in that account, everything inside that account first. Want to also bring in the public key, add a public key. Public key going to be this C. There is something called C.public key, okay, and then you want to convert that to base 58. Okay, so this we convert it to a string, a public key that is in its format, public key version. You want to convert it to string. All right, so you want the ID of the poll, which should be c.id, .account first, .id, and you want to convert it to number. Okay, and you want to do the same for the start time and the end time. Okay, so we have the start time, modifying this. All these are by default, they are not number, they are in this BN type. Okay, so for you to make use of it, you need to convert it to number. That is what we can deal with on the front end. All right, but you want to multiply this by 1000, because when I was creating this, if you look here, when I was creating it, I divided it by 1000, because the Unix timestamp record time in 10-digit figures. But if you check the date.now on the browser, it's going to give you 13 digits. So in JavaScript, something like date.now, the timestamp version is actually 13 digits. If I do this, doesn't just allows me to paste. So what I can do is say dot to string, and then say dot length. So you can see that this is 13 digits in this place, but the one that is coming from the blockchain is 10 digits. So I need to make sure that it's 13 digits so that it can match with our timing and not cause some confusions for us. So that is what we're doing here. We're also going to do the same for the end. Okay, and lastly we need one for the candidates. Okay, so we're going to call this candidates. Okay, so with this we're going to return the appropriate, this will be very much in line with a poll, an array of poll. This is going to return an array of poll that has been streamlined for us. So you can see that we didn't bother about the description, because the description by default is a string and we don't need to modify it. So at this point, I will say you should return, this serialize poll, and I'm going to pass these polls inside. All right. So, and this will grab us all the polls that we need, and we can interact with this on this other part. We come to this page. Okay, we incorporate it into our fetch data. If you look at this function here, so we can call, say, const, say, polls. Okay, so now we're gonna have to be a little bit careful. We'll say this fetch poll. Okay, I need to import it from the blockchain service. This fetch poll, I want to pass not this program, but this read-only program, because we're not writing to the blockchain. So we want to pass that read-only program, and when it comes back, it's a promise, so I can use this then statement to capture all the polls. Okay, and I could call this data. Okay, and convert this into a use state. All right, so currently now we can use it that way. So we want to say const polls, and we have set polls, and this is going to be a use state, empty array, but we want to typecast it to be poll array. Okay, so at this point we can come and say set polls, and you pass in this data in here. So this way, make sure that these polls are properly set. You get, so this will make sure that we have polls reading from the blockchain. So let's save that and see. Save it. You can see that we have one poll here. So I'm going to go again and create another poll. Let's create a new one. Call it best sport in the world. So I'm going to say it started yesterday. All right, and it's going to end this day. Okay, so, and then I click on create, unlock my phantom, and wait for this, since it's on localhost, so it's just making some connection, and then confirm it anyway. So you're going to have to wait, because it needed to be finalized on the blockchain to really confirm that everything works. So fingers crossed. So it's created, and when I come here, you can see that it's just right here. So this is how this works. Very clean, straightforward, and very effective. All right, so that is how you read a specific poll. Now look, whenever I hover to each one of these poll, for example, if I come here, you can see the poll address, right? The poll address for this particular one. This is the poll address. When I come here, this is the poll address for this as well. So you see that each one of them are different. So let's move forward. Let's read these polls as well. But before we do so, I want to first resolve this thing that keep popping up. I want to make sure that it's reduxified. Right now it's just dummy. So let's reduxify it. So to reduxify that, you come to this reg candidate. This is candidate registration portal. So at this point, this set modal visibility, this is what is triggering this. So this was supposed to be dynamically. So we can't use this format. So I'm going to remove this, and I'm going to remove this as well. I'm going to remove this for now. This will come back to that. So, but what we're going to do is let's fetch some information that will help us to do this very well. So we want to get dispatch, okay, from use dispatch. Okay, this is coming from React Redux. We're going to need that. We're going to also need these actions. What is it called? From global actions, which is coming from the store. Not this one, but the one coming from the slices. Okay, so from that one, sorry, you don't need to put this there. So from this one, you want to say we want set reg modal. Okay, we want this so that we can use it to make some modification here. So I'm going to say dispatch set reg modal, this one, and I'll pass that scale of 0 to read. So because this is what I use in closing it. Or what if I want to open it? Okay, I will do the opening on another page. So, but I also want to read the content. I will say const. Okay, so we're going to call this one use selector. Okay, this is how you read. This is for writing to the store. This is helpful for writing to the store. This one I'm about to do is you use it to read from the store. All right, so we're putting things in the store using these functions, and we're using this to read things from the store. So we'll say use selector, which is coming from React Redux as well, and I'm going to call this state. Okay, this state is going to have a root state type, and I'm going to call on this state, call on this global state. Now I can have access to that reg modal. Okay, now this reg modal, this is what I'm going to use to regulate the visibility of this modal. So I will say now, okay, this reg modal. All right, so save that, and when I come here and refresh, it shouldn't be showing up again. But if I want it to show up, I want to be able to click this and it shows up, but now it's just showing me an alert. All right, so I'm going to come back to the details page. So if I come to this polls, you can see that, and then this poll, the ID. So I enter here. This is where I found the details of a poll. And now all I need to do is I'm going to have to call on these two functions again that I used in setting things. So I'm going to get those two functions. So get the dispatch and also get the global actions. And now when this button is clicked, this button that has an edit, okay, instead of handle this set stuff, instead of handling that, we can actually do it straight from here by saying, dispatch, set reg modal, and you want to scale it to 100. All right, so you have that, and we don't need this alert anymore. Okay, so when you do that, you save, and let's look at it in action. So when I click this, it pops this. When I click that, it goes away. Click this, it pops this. Click that, it goes away. So that is what is happening now. So at this point that we have that functioning, let's read, using this ID, because with this, if I search it out on this place, you can find out this particular poll. So this is the poll. There is no transactions that have happened yet in it, so there's no candidate that have been created that is attached to this poll. So this poll is just completely blank. It was just created, okay? And yeah, so that's the poll, the program derived address for these things here. So what we want to do is to read this data accurately. Okay, this data is not accurately pulled. This is a fake data. All right, so to do that, and we need to write the function for reading a specific, poll on the blockchain side. So let's get there. So I'm going to call this fetch poll details. Fetch poll details. So if I want to fetch a poll detail, I would definitely need the program ID because everything has to communicate through this. And I will need this address. Okay, so how I will get it in here is by saying poll address, and it's going to be a string. Okay, so I have those two, and at the end of the day, what I want to retrieve from the blockchain is a promise that is returning a poll. Okay, so now I want to do something similar to this here. Okay, so I will just call on this pool, but instead of grabbing all, I want to fetch a specific pool by just passing in the pool address in here. Okay, now I have that pool single, and I have to serialize this pool. So I want to serialize that pool. Call it const serialized is equal to this pool, but this pool is just a single object, so I need to put it in an array. So I get a serialized pool, but I can't make use of it this way. I need some modification, so I can't use it directly with this function because I need to pass in some vital information. For example, this is not going to be available in this object here, so if I'm passing it through this means it's going to be producing error, so I have to modify it myself and add this string right here. And to do that, would say this serialize is going to be of type of pool, and this is an object of course, and this object I want to destructure this pool first. Okay, and I want a public key, but this time this public key is going to be different. Basically this is the only difference between these two. Okay, otherwise everything should have stayed the same. So what we want to pass here is this address. Okay, so we're going to pass this address here. That's the public key, and the rest will remain just about the same. So I'm going to copy this and paste. Okay, and make sure that this c.account is now pool. All right, so with that we have a serialized pool, and I want to actually store this in the action. So if I come to global actions, okay, see we have a place for storing set pool, just like we've been dispatching or interacting with this. We use this to communicate between components. We use store to communicate between components, where they can just have a general container where they can fetch shared data. Okay, for that registration modal, where I could switch, pop up the modal from another page, and it being in another container or another component to pop up, and I can close it, so I could communicate between components using a Redux Store. So the same thing I want to do for this poll. Why I'm setting it, I want to use the store, is because when I'll be making voting and creating new candidate, I want that to be updated at every time, so I could easily just update the content of the store and it will reflect on the page just fine. So what I'm going to do is no different from what I've been doing. I'll say const this a global action. The one is coming from global here. So I'm going to say set poll. This is what I want. And for setting of poll, you do see here that for me to utilize, where's that place? Okay, so before I will have to call on dispatch, I will have to say use dispatch to be able to interact with the store. But since this is not a React component, those who use dispatch or use selector, they are all for the they're basically for the React component, but this isn't a React component. So I need to call on this store directly and call on this dispatch. Okay, and from this dispatch, I will say set poll and set it with this serialized that I just got, and after that I could return this serialized as well. Okay, so that when I call this, it will just deposit all this stuff in the store, but I could also retrieve the value from here, from the function directly if I want. So it's a two-way method of capturing results that comes from the blockchain. So at this point, we need to gonna need to read this data from the blockchain now. Okay, and we'll need a use effect to perfect that. So what I mean by this is this value needs to be coming from the blockchain, not this one. We'll come back to this, but this one here needs to be coming from the blockchain. And how we do that, including this here, okay, first of all, I need to correct this. This key is not correct. This is not how we get the key. What we're trying to get is to retrieve this. To retrieve this, you need to use another function. Say, let's call it use params, and it's coming from Next.js navigation. Okay, and you want to call on this poll ID. The name poll ID must be equivalent to how you spelled it here. You can see this. So that also, tallies with this here. So that is what we meant by the poll ID. Okay, it's basically the address. All right. So with this, okay, we would not need that public. Okay, we're also going to need a public key. Okay, there is a public key. You know how it goes. We want to call on this const use wallet. Okay, I could remove this. Okay, and use that public key and use this public key. Great. So here this is declared, but it's never used. Now we need to write a use effect function. So it's a use effect. All right. So when you're using effect now, you want to say if there is no, because you can't call a use effect if there is no program. So you want program to be available. Say program. If there is no program or there is no poll ID, then it should just return this. Now this here, I needed to make sure that it is put in a functional format like that. So this is important, but I will need to get the program right. So this is going to be something similar to this, but I'm supposed to use the read-only method. So come here, and since I'm only going to be using this program, make sure that I import this use memo and also import this. So I'll pass in that program is now available. So I'm going to call on this function, create a function called fetch details. So let's actually fetch the details from the blockchain. So I'm going to call it, say async, and say await, call it fetch poll details. It's coming from the blockchain, and you're going to have to pass in that program. Okay, and you also want to you're going to have to set that poll ID as a string. You get that? So these two things, even without me trapping the the results, it's already been stored by me calling it. It's already been stored in the store because of these. If you come here, because of this, line of code that we set up here, it's been stored in the store. So I just need to retrieve it from the store. I just need to retrieve it from the store, but I need to execute this fetch details. If not, it will not run. And there are some things I must put in this dependency array. What I used, this program must be there, this poll ID must be there, because if any one of those things they change, it will also change. Okay, those two things are quite important. So for now, let me grab the poll. These polls cannot be coming from this. This is not where we get the polls, but we're going to have to get the poll using another method. And let's just, take this line of code here, come here, okay, say root state, make sure you import that use selector as well. What I'm grabbing is the poll. Okay, this is a single poll, and that is where I get my poll now. Okay, so without this, basically it's resolved. When I save this, and you can see now that these details are coming. This is the original details. These are coming from the blockchain directly. And I come here, click on best field of education. You can see all those records are coming directly from the blockchain. Okay, this is good. So in the next part of this video, what I want to do is to help us to register a candidate. So let's go and do candidate registration straight up, and then from there we can also do other ones. But before we go there, I want to show you something. When I open this particular page, and I'm going to use this one. Okay, I'm going to disconnect, make sure I'm disconnected. Okay, so I will visit this best field here. You can see that because I'm not connected, this button is basically going to be a dummy button. There is nothing to click here. Okay, but this one that I'm signed in, it gives me the ability to register a candidate. So in the next part of this video, we're going to come into the registration of a candidate now. All right, I'll see you next. Okay, so to register a candidate, I'll need you to come to the blockchain space. I'm going to close from here now. I'll be back. So come here. So just after we create a poll, I want to create. So this another function that will help us to register candidates. Okay, and you know the drill. To register a candidate, you're going to need these two things first. You need these two details, the program and the public key. After I get the public key, we want the poll ID. This poll ID this time is actually the number. Okay, so each poll has a number. Okay, like poll start counting from 1 2 3 4 5 and so on. So we need that poll number, and we also need the name of the candidate. Okay, so the candidate name, which is a string. You remember we have this modal that helps us to enter the candidate's name, so we want to use that as well. And what we want to return is nothing too different from here. We want to return a transaction, a transaction string or ID. No, sorry, not here. Okay, so we want to return a transaction signature. Okay, so at this point we need const this PID, which is the poll ID. We want it to be, because this is a number right now, I want to convert it to a BN type, which comes from Anchor. So I want to say new BN. I want to put that poll ID here. So we have a poll ID, and when you're creating a poll, remember this is how you form the seed, the program derived address. So we want to form our own program derived address, but this time we need to use this here. Okay, so this will get us the program derived address, and you also need the registration PD as well, which you can easily get not here, but when we're initializing, we created this, so we can just copy this here and not have to write it all by ourselves. So this is the registrations PDA. Okay, so you need that one as well, and you want to get the registrations because that is how we're using forming the seed. So reg say await, we say this program, we call on the account, we call on the registrations, and we call on this fetch. We fetch it by that registration PDA. So once we get that registration, we want to form our CID. So this will be the candidate's ID, the one that we want to use in giving this candidate that we're about to register. So we say regs.count, and we want to add a value to it. So it's going to be a new BN. I want to add 1 to it because this candidate ID starts from 1 and not 0. The default is 0. So once we get that, we want to form the candidate PDA as well. So I'm going to copy this line so that we can modify it a little bit. I'll call this candidate candidate PDA. So what we're going to do here, we'll keep this here, but this is not going to be the only item that makes for that seed. So we're going to need this CID as well. So we can duplicate this line and change this to CID. Okay, so we have those two values, for forming the seed of a program, a candidate, PDA. All right. So once we have those, then we can perform the process of creating or registering a candidate. So we say TX for transaction, say await, and we'll call on this program, and we say methods, and you want to say registration. Okay, make sure that it's in another line, registrations, and then you want to call on these account partials. Okay, we're going to come to them one after the other, but let's start with this here. Of course, you also want to say .rpc. Okay, so let's come to this place first, and we want to pass. For you to register a candidate, you need the poll ID and the name of the candidate. Okay, so let's pass that. So we say poll ID, this PID. Okay, and we also want to pass in the name as well. Okay, and here let's work on the account partials. We will need the user. Most of these things we've already created them, so I'm going to copy this so that I won't have to repeat myself too much. I'll paste this here, do some modifications. So for example, this user is needed. We need a poll and not counter PDA. So we'll say poll PDA. We already have that here, and we'll say this registrations. I want this registration PDA. We also need the candidates, all right, and the candidates PDA. So these ones will help us to create a poll. So we have 5, 1, 2, 3, 4, 5 accounts that's being sent together. All right. So after this, the drill. We can copy this last line for verification to make sure that this transaction is confirmed and added to the blockchain and finalized before it releases. So I'm going to paste that here. Okay, and that is basically all there is about that function. It may look lengthy, but it's just very simple. Follows that same pattern that we're using for a long time. So you save this and come here. Okay, to this registrations component. Now I want to register a candidate, and let's get it rolling. The first thing I want to do, I want to make sure that we do have a program. Okay, if there is no program or there is no public key, or there is no candidate name, it should just return. Now we have this variable, we don't have this and we don't have that, so let's get those values available. And to get it available, we can easily just copy this, right? Copy that and paste here. So we have access to that public key. Now this program, we also need that, but the program is not going to be a read-only program. We want a read-write program, and to get a read-write program, we can get it from this page where we had this one. Okay, so I'm going to copy that, and bring it here. So I'm going to make sure I import this use memo and this as well. Get provider from the blockchain, and make sure that I also bring these two guys from this same place. Okay, so we have the details for making a program here. So that is cool. At this point, everything is all aligned for us. Now let's, instead of having this dummy stuff, let's write real stuff. Okay, so let's say this is a try catch. Let's call on that transaction. I want to say tx is equal to await, what I'm waiting for, register candidate from that blockchain, and I'm going to pass in this program, and I also want to pass in that public key, and I want to pass in that poll ID. Here's poll ID. Hope we're getting that correct. Poll ID, where is poll ID coming from? It's coming from this prop here. So we're passing that poll ID, and we're also passing the name, which is this candidate name. Okay, so those are the details that we are passing, and it is complaining about this. I want to make sure that we have an async function here. So at this point, you want to clear up that candidate. Say set candidate with this, and you want to dispatch and say set reg modal. You want to make sure you disappear that modal, scale back to 0. Okay, after you do that, you want to then say await fetch poll details. Okay, so in setting bringing poll details, you want to pass in the program ID and the poll address. Okay, which the poll address is coming from here as well as that. So this will update the record on the record that we have. That is the number of candidates will increase from 0 to 1. So you just basically update this record here, at real time for us, so that it won't have to refresh the page. And then you want to log out, the value, say tx. Okay, and you say resolve that tx as any, of course. So there you have it for now. Let's save this and see. Save that and just do a quick refresh. Let's register a candidate. Best field of education, say computer science. Okay, so let's register that candidate. So this is one of the candidates for the poll, what people are going to be voting on. Confirm. Let's watch if this updates to increase the number of candidates. All right, you can see that this is happening because of reduxification. So it just updated what is in the store, and what is in the store then appears here because this is gotten directly from the store. Now these are still dummy records, and they are not useful to us right now. So we need to fetch the real details from the blockchain itself. So we need to write another function for that. So I'm going to close this and come back to this. I could copy this and say fetch. We'll say fetch candidates. That's what we'll call it, fetch candidates, or fetch all candidates. All candidates. Okay. In fetching all candidates, I don't only need the program, I also need the poll address, because I need to know which poll I'm talking with, right? I want to retrieve, data from. Sorry, I want to make sure that they have this. So now, so I want to return candidates array, an array of candidates. Okay, so at this place, I want to say candidates is equal to, you call on this candidate right here, you call on all, not all, sorry, yeah, basically all. Okay, when you grab all the candidates, want to first check, want to fetch the poll first. Okay, let's take this one after this, one step at a time. Once the const poll, want to make sure that the poll exists. So say poll data, okay, or just poll is equal to await. Since this is an async function, we want to call on this specific poll, say fetch poll details, and then you pass in that program and the poll address. Okay, so it fetches the poll for us, and we say if there is no poll, you should simply return an empty array that satisfies this candidate. But if there is poll, that means we can get some candidates. Okay, so if there is a poll, first of all, we want to say const poll ID is now going to be new bn, and you pass in that poll dot that ID for the poll's ID, and that will give you that the poll ID. And we can grab all the candidates now. After grabbing the candidates, okay, and we can call it candidate data. Okay, after grabbing all the candidates data, you want to say candidates now is going to be called to this candidate data. Okay, and then you call on the filter method because you want to run through each one of them. Since it's an array of it, you want to run through each one of these candidates. Okay, and you want to perform this filtration method on it. So you want to return a candidate that the account and the poll, this poll ID for this candidate, okay, is equal to this ID. So for all the candidates that belong to this poll ID, I'm going to grab them all. Okay, which would have been cool if there was a way, maybe I don't know, but I don't think it's pretty much there, but for now. But if there is a way you can just get all this and just filter by this poll ID, right from that function right there, it's going to be like a pretty good addition to that that Solana can actually put to make the writing of this a lot easier. But this way actually works as well. So this will return all the candidates that belong to that pool only to filter those, and it can now return a serialized candidate. Okay, so say return, and we can say candidates as unknown as candidates array. So this kind of satisfy this function, okay, but we need to make some modification. We need to streamline this, and we need to actually store that candidate inside the store. We need to put it to save it in the store. So before we do that, we want to create a function called serialize candidates. So we want to streamline candidates. Say serialize candidate is equal to a function that takes in candidates, okay, and is of any array, and it's supposed to return a candidate array. Okay, so and for each one of those candidates, I want to call a mapping on it and return a mapping, an object of each one. So I'm going to destructure this one account, all right, and say public key, something similar to this as well. So I'm going to say public key here, okay, and we need the CID, which is the candidate ID, which is c.account.cid.toNumber. Okay, this is important to convert the ID from that, from the version that comes from the blockchain into a number format, so that it can be represented on the interface properly. So I'm going to also do for the poll ID as well, and want to do for votes how many votes does a candidate has for votes, and also the name is not necessary that I must include the name here because the name is a string, so it will be retained. So I can use this to say return serialized, and I could forget about this. Yep. And I could also set the candidate here. So we have set poll, we also have set candidate. Then I could say this store.dispatch, serialize candidates, and say set candidates, and then what you're passing is the serialized candidate, then you're passing in that candidate. There's a lot of function, deep level 1, 2, 3, 4. If we add this 5, so that's a lot of deep level of cascading. All right, so I'm going to call this here. So immediately after fetching the details, I also want to fetch all the candidates, and to fetch all the candidates, what I need is the program and the program address, which is exactly the same thing for fetching the poll details. So with that, you save, but that isn't all. You need to now come here and make sure that these candidates are not dummy, but they are coming from the store directly. So I'm going to remove all this. Okay, you can see it's giving me error here. I'm just going to call on that one that is coming from the store candidates, and that resolves it. Okay, hopefully. But also I want to make sure that I'm fetching the all candidates here as well. So we have those two, and we can remove this here and save, and let us see in action. You can see that we only have one candidate here. So let's create another candidate, call it what other popular field is in terms lately? Let's say engineering. Okay, engineering. Let's register that vote. I want you to watch number of candidates. And currently, before now, you saw that we only had one field of education. So I'm going to confirm that. And once that is, completed, we are hoping that it's going to reflect there both the number we updated and the number of candidates you can see. All right, you can see that those two are being represented properly. And even when I come here, let's refresh. No, not best sport, but best education. You can see, it's also being reflected here. This is great. Coming back here. So in the next part of this, what we want to do, I think that would be like the last set of operation for this, is to ensure that we can vote. Right now, these are dummy votes, they are not working. So let's make sure that we can actually vote for, the poll, the candidate that we want to vote for. All right, so to vote, we need to come back to, we're done with this place. For now, let's just jump into, this is the candidate list. This is the list that shows you all the people the list of candidates that are available for voting. Okay, so this is where we're going to perform the voting. But we can't do anything until we provide a function here that will make that happen. So I'm going to close this. And after this register candidate, I'm going to write another function. I'll call this just simply vote. So now I'm showing you a pattern. This is the pattern that you can use when you're writing your Anchor program. You won't find a lot of this on the internet, at least on the public domain, but this gives you like a full breakdown on how the entire thing works. And this is pretty much of a matured way of handling it, so like this, I'm going to need this information. Okay, so I'm going to come here for the vote. I need the program, the public key, the poll ID. The name is going to be candidate name, candidate ID, sorry, not name. Candidate ID is going to be a number. Okay, so we need all that. And we need to return a transaction, record, of course, promise of transaction. So we see here, do this. Okay. So at this point, we need to make sure that we convert. Let me open this. This particular thing you did here, let's do it here. So we do it for this poll ID. We also want to do it for CID or for this candidate ID as well. Okay, so we've gotten the BN equivalent of those. Now let's get the poll, this poll. I think we can easily get that from this. So here, this is for the poll PDA. So this grabs you the polls PDA, and you also want to do for the voters. The voter is a little bit different, but it's based on the same principle still. So I'm going to call this voter, voter PDA. And in this voter PDA, it's going to take a little bit of a different shape. So let me break this into multiple lines. So I will say that buffer, okay, this buffer, say dot from, okay, and then you call on this voter, that keyword. All of these things are based on that, all these are based on what we've already done here. You can see how we specified it. All these things are basically the same things. Okay, we've run the test. If you haven't watched that, part 1 of this series, you should go and do that. So we tested it. It's the same ideas that we're using to make it accessible, via the browser. So we need that. We also definitely will need not the CID, but we're going to need the public key here, the public key of the person that is currently, trying to vote. Okay, so to do that, that is where this public key comes in. We say public key, and then just convert it to buffer. All right, so that will give us the voter PDA. Okay, and we also need one more PDA, which is the candidate PDA. We can easily get that when you're registering a candidate. Remember, this is so we can copy this and bring it here. Okay, so all the PDAs are ready. Without these PDAs, generated accurately based on their seed, you will get things won't just work out. Okay, that's just what you should know. So I'm going to copy this, okay, all the way here because they are all similar. So I'm going to copy all that and bring it here. Now, you don't want to register a candidate, but I want to vote simply. And in voting, you will need the name of, you need the poll ID, the candidate ID to vote. Poll ID and candidate ID to vote. So I'm going to say poll ID here and then CID, which is the candidate ID. Those two helps me to vote. And this user is accurate, this poll is accurate, and candidate is accurate. Now we need voter, okay, which is the voter PDA this time. So these are all the records that it will take you to register, perform your vote. So now the vote has been performed. Okay, but yeah, for now let's keep it that way. Okay, so let's save it, close this, and come to this candidate list. So this place, let's remove all this. All right, so let's vote. Okay, so this function called handle vote, the first thing you want to do is to check if there is a program, of course. If there is no program, or if there is no public key, and if this candidate has voted, then it should just return null. So let's make sure that those conditions are properly being cared for. So for this voted, it's just going to be a use state as it is right there. And so we're going to need this record, we're going to need that. This is the public key, and this is transaction details for. We need this to be able to form our program. Okay, so this is our program. I'm going to copy it, bring it here. Okay, make sure I import this memo and get the provider from blockchain service. So you can see all this information are ready, totally ready. Okay, so at this point we can proceed to voting. Okay, and to vote, and make sure that I put an asynchronous request here, and then you come here, you say tx, which is const tx is equal to await vote. It's coming from the blockchain service. We need that program passed in. We'll also need that public key passed in, and we need the poll ID. How do you get the poll ID? Is by consulting this specific candidate here that is coming. So this candidate, okay, dot the poll ID, and what else? You also need the candidate ID. So you say candidate.cid. So these are the records that you need to successfully vote. Now, after that vote has been casted, we want to fetch the candidate. So we can do that by just calling, this, say fetch all candidates. So when we fetch that all candidates, if they had 0 votes before, anyone that was voted for is going to be increased right there so that you can see it yourself. So we say fetch all candidates. Make sure you import this, and this address, this is the poll address, is coming from this place. So we need to make sure we have a poll address listed here, and this poll ID, we're going to need it later on, but I'm just going to include it here. Okay, so there we go, and we fetch this, and make sure that you log out you log out the transaction, and after you log it out, then you can resolve this. It's as any. Okay, so here we go. So let us save this and watch this in action. Let's watch it and see how it goes. Okay, so now let's vote for computer science, because I actually have a computer science degree. So I'm going to say vote for this computer science, and let's watch it happen, at real time. So confirm, keeping our fingers crossed to see which one will be incremented. Okay, you can see that it increased by 1. This is cool, and that means this is working. You see, but there's one more problem. After voting, after it has successfully voted, I don't want this button to be enabled anymore. I don't want people to even have the chance of attempting to double vote. Okay, even though it's gonna fail, because on the back end the smart contract doesn't allow that. We've already coded those instructions. I don't want me to be able to click that again. Okay, if I've already voted with this address, except I'm using a different address. Okay, so to prevent that double voting thing, we need to create another function that we regulate that instruction. And to do that, we're going to have to come here to the blockchain service. Okay, and we'll create another function, and this function is going to simply say has voted. So you're going to check if a certain user has voted or not. So I have has voted. Okay, so we have has user voted. What are we going to need? We're going to need the program and the public key and the program ID. Those are the things we need. Okay, so right. And what are we expecting to return? A promise of a Boolean key. So Boolean. Now we want to make sure that we grab that program ID. All right, we have the program ID and want to form that voter PDA just like we did before. So I'm going to copy this line, get that voter PDA. And then what else? Once that voter PDA is ready, you want to perform your try catch. Okay, if you have any errors, just return false. Okay, say error fetching voter account and then return false. And then you want to get that voter. Okay, so you say const voter is equal to await, and you call on this program dot, you call on the account, you call on the voter, and then you say dot fetch. You're fetching a specific voter by that voter PDA. Okay, if we do have a voter, if there is no voter, okay, in essence, if there is no voter, then it should, if there is no voter, or when I call on, if there is no voter, you know that we have voter, then when you access it, it has voted is false. Okay, if has voted is false, then it should also just return false here. False. Okay, otherwise we just want it to return true. So this is the condition that guarantees that we can check if a user has voted or has not voted. Now with this information, we can check it here, use a use effect to check and make sure that a user has not, if the user has voted, we can block off this. We've already set up the instruction to determine, like for example, by default is false, right? You can see how this class was modified to give room. If a user has voted, it's supposed to show red, but if he hasn't voted, it's supposed to show green. And this hover state is only supposed to show if the user has not voted, and is disabled if the user has voted. So now to get all these things together, you gotta use a use effect. Okay, so we come to here, we say use effect, run that. So the first thing you want to do, you want to check if there is no program or there is no public key, you should just simply return. These things are a way of making sure that you're safe. Okay, then but if that is the case, if those two exist, you want to create a function here. Say const fetch, okay, voting or vote status. Okay, so it's gonna be an asynchronous function. So vote status, and you want to call on const status is going to be equal to this await column has user voted. You grab that, and then you pass in this program. You also pass in the public key. Okay, and then you pass in that poll ID, which was very important all this while. Okay, and that will give us the status, which is Boolean true or false. Okay, so then you just set voted to be whatever this status tells you. Once you do that, you can call this function here under the conditions that it passes this, and then you can say fetch vote status. Okay, fetch vote status. Okay, so there's some things that you need to put on the dependency clause here. For example, you want to put this program, so if the program changes, something should change as well. You want to put this public key in case the user signs out, and you want to also put this candidate as well. I know that it doesn't satisfy this, but that is enough for us right now. So let's save this and check it out. So save that. You can see that this thing is completely disabled. It's not going to allow me to do anything anymore. That is it. It's disabled, but it is disabled. So I guess what I'm just wondering is, if it is voted, it should show red, but it isn't showing red. Say BG red 100. Let's save that and see. So I guess let's do this way. Else green. I can remove this. Save that. Let's see. Okay, so I guess it's working now. So voted red. Okay. Yep. So that is showing that I've already voted and it can't do anything about it anymore. So, and when I come to best sport in the world, let's say cricket. Okay. Let's add cricket to that list. Confirm. Okay. You can see it's showing green. If I also add something like soccer, okay, create that, and then confirm. So you can see these ones that have not been voted, they are showing green, which is great. So at this point, we've been able to, do every single aspect of this project. If I check it from this browser, let's just leave it that way, okay? I don't want to go through a lot. You already know that everything works. So this is it, all the project, every angle of it is showing. Okay, so that is it for this particular tutorial, but we're not done. There's one more step that I want to do, just for as an added advantage. I want to, show you how to deploy this project, on the smart contract. I want to help you deploy it on Devnet, okay? So I'll see you in the next part of this tutorial so that we can do that once and for all, and we can run this, close this. Now, to perform a deployment, this is the last step that you need to take. I'm going to close out from these things. Okay, let me close out and let me show you. When you come to this Anchor program, you find out that this, okay, I'm just going to make sure that both the local net and the DevNet are using the same, address, and I want to make the default one the DevNet because I want to deploy to DevNet right now. So I've set up these things this way, and I'm going to head to CD to Anchor, and I just need to do Anchor deploy. Make sure that you have some Solana balance on your wallet. So Solana balance, how much you have, this is a lot. So, but you see that is from my local, local this thing, what is it called? This is my local balance from my local network. So I need to say Solana, what is config get. Okay, I need to make sure that I am on the DevNet and not the local net. So I will say Solana config set, and then you say URL and you say DevNet. Do that. So this is now on the DevNet. So I will then, when I run Solana get, Solana config get, you can see that this is now DevNet. And when I check on my balance, Solana balance, you find that I have 7. I don't think that is quite enough. So, but I can say Solana, airdrop, and say ask for 10 Solana tokens. So I have, that has been credited to me. I think you can only do this like once a day or once in like 30 minutes. So when I do Solana balance, I have about, I should have about, it's not yet confirmed. Let's say Solana address. So let me check it out. Come to the browser. Make sure you come here. I'm going to make sure I'm in the DevNet this time. So search for this balance. So therefore, where did I wish I could request again. I totally don't understand which wallet address that went to, but I kind of requested for 10 token. But there's no problem. I think I do have sufficient. I think it's sufficient enough to deploy this. So let's run that. So say anchor deploy. Make sure your internet connection is fast, and make sure that you have enough token so that this thing can deploy in peace. That is one of the challenges that you may face if you don't have a fast internet connection and you don't have enough Solana tokens to perform that activity. So I am getting this error. This error also appears. Sometimes it is due to internet connection. It is also due to shortage in your Solana balance. So if I check my Solana balance now, okay, so this seems to be an issue sometimes. Network connection is a big deal, in this. This is one of the things that I do face, but let me see if I can top up my Solana wallet. Let me see which one is my Solana wallet. This, copy this and come to this. I think I have some Solana tokens here. Let's make sure we are on the Devnet. This has 9. I'm looking for one that has a larger proportion. Okay, let's use this one. Let's send to this recipient, max it or send to me. So say view transaction. Just let it be. I'm gonna come here, and when I check, refresh this page, this should increase. Yeah, about 15. So let's check it out again. I don't know why Solana behaves like this. The speed, fails sometimes. Otherwise this shouldn't be failing. The internet connection is working and all that. So let's try it again. Anchor deploy. Okay, hallelujah, it actually deployed. Okay, so when I copy this address and come to the Devnet, paste it and go there, hallelujah, it's actually deployed, and we have the contract online. Fantastic. So what we need to do now to switch to that Devnet, I want you to, let's see the back. Okay, I want you to open that environment variable, and we're going to toggle this for a moment. Remember, since I haven't saved this, if I save this, it's going to be pulling from the one on the blockchain, on the Devnet. So when I save that, you see that it's showing me the one on the Devnet. So this is Devnet interface now. One of the things I want to do, I want to make sure that my account is switched to the Devnet. Okay, so I'm going to make sure that it's on the Devnet. So refresh and then initialize this. Okay, see how fast it is. I just confirm, without having to wait extensively. So it's approving transaction. Okay, so that has been successful. Now we can create a, let's say, best safest country in the world. Okay, and let's say started. The reason why I'm starting it later, because I don't want to have to wait till tomorrow before I can vote, so that's why I'm doing it right away. So this ends in this day, 7th. Okay, so let's create that approving transaction. You see everything works faster now on this live interface. So this is on the web. all you need now is to deploy your front end along with the environment variable, on your internet connection. It could be Vercel, it could be any other one. You can see it's listed here. So we can create a candidate. We can say El Salvador. Okay, hope I'll spell that correctly. And then you confirm. It could be so it could be Vercel, or it could be any other provider, and then you put your website there, and all these things will be online already. So this is really cool. So we have that, and also have we can also have let's say Spain. You can have more than 2 candidates. You can have as many candidates as possible. So let's do that, and let's have 3 candidates this time. I'll put England. I heard that it's on the news that England isn't that really safe right now. So England, and see, confirm that. So it's quite a very terrible turn of an event. England would have been considered the safest country amongst this list, but the most crazy country in criminal activities, El Salvador, is now actually the safest, while England is like not too safe anymore. So I'm going to vote this one, all right, and confirm that. And I'm also going to get other people to vote, okay, so I can have more than 1 vote. Okay, you can see 3 candidates, so this has been voted. Let's check for another candidate. Oh, I only have 1 candidate here. Okay, there's no problem. I will come to this other browser. Come here. So I make sure I'm on the Devnet. Okay, I'm on the Devnet. So let me connect to this. So I'm connected using Phantom. So view here. So I've not voted. I can also still vote for El Salvador here. Okay. So let me cancel for now and make sure that I do have enough. So I don't have any Solana token on this. So let's look for one that will have Solana token. Okay, this one. Let me disconnect and let's reconnect. Okay. That's that. Let's reconnect. Okay. Confirm. Ladies and gentlemen, that works just fine. You can see that, this is great. And this is what we are looking for, and you saw how this actually jumped from, there is, I don't know why it behaves like that, but I'm sure you can set up a little algorithm to make sure that it orders this by name, okay? So that is it. Everything works just fine. We've actually deployed it online. The only thing that we didn't do is to deploy the front end, which I'm going to leave it to you to do that. I've also shown you how that I deployed mine on Vercel. This is the one that I have on Vercel here. You can see this, web address, and it's literally living there, and that is to show you that everything works just great. Ladies and gentlemen, I am pretty glad to have concluded this full stack Dapp, development on the Solana ecosystem, precisely using Anchor/Rust to build our smart contract from scratch. We built every single angle of this thing, and I'm pretty glad to have crushed it along with you. And I hope that this has been very fruitful to you, and it's going to add up to your productivity and help you to crush a lot of projects. With that being said, there is many of these that we are thinking about bringing into the channel, and you can help us, by just liking and subscribing our video, recommending, sharing, and all that. That will really help us, because we are still growing, a growing channel, and many people don't know about us, but that are needing this sort of training. Okay, so that is just all we're going to ask from you guys. All right, so that will be it for this particular tutorial, and in the next one we'll also have a surprise, but I don't want to say it for now. But we're going to be working on it right away to get something. Let me give you a hint. We've been able to do all those transactions and stuff. What about for monetary service? Something that involves transacting money as well, like a crowdfunding system where payment is done. So something like that. That is what we want to also implement on this channel, to give a full stack experience of building a Solana application and hooking it to your front end. So my name is Darlington Gospel, and I'm going to see you in the next tutorial. Bye-bye.